So here we've got a question that involves shapes, and it's given us the height of this shape, and when we look through we can see some key information. It tells us that the surface area, and is also making large monsters with another height. Right, now here's the key bit. They're telling us these shapes are mathematically similar. So what we've got to remember about mathematically similar shapes in 2D and 3D is there's some fairly basic formulas. So the linear scale factor is the new length divided by the old length of corresponding sides. And then we have the area scale factor. So when we're dealing with areas, then that's always the linear scale factor squared when they're mathematically similar. And then we have the volume scale factor, which is the linear scale factor cubed. So as soon as we see mathematically similar, we should be writing down the key facts that we might have to use within this question. So let's have a look then. So it says work out the surface area. So that means we need an area scale factor. To get an area scale factor, we need a linear scale factor. So the first thing we've got to do is work out what the linear scale factor is. Now they told us that the height of the new shape is 120 and the old shape was 20. So that gives us 6. So the area scale factor is the linear scale factor squared. So 6 squared, that's equal to 36. So it's asked us to work out the surface area of the large monster. So the large monster surface area equals so in this case it's going to be 300 times 36. So non-calculated paper question, so we've got to do this in whatever way we can cope with. Personally I'm going to do 3 times 36, which is 108, and then I'm going to do 108 times 100. So that's going to give me 10,800. So the answer here is going to be 10,800 square centimetres. So 300 times 36, do 3 times 36 first, 108, and then we're left with 100 to do because of the 3 times 100 equals 300 back. So the answer here, 10,800. So the key idea was mathematically similar tells us we're going to use either of these formulas. Might even use all 3 of them, depends on what the question is. And because of the way the information worked, then work out the linear scale factor by doing the new length divided by the old length, 120 divided by 20. Area scale factor is then this squared, and then the large shape surface area must be the small area times the area scale factor.